Hello. Ooh. Hello, Gophers. My name is Paul. This will be testing the database with interfaces and build tags. So this is a small pattern that's come up across different projects over a couple of years of doing Go. So I figured maybe there's something there that'll help other people. I'm going to spend about 10 minutes talking about this. We'll spend a little bit talking about interfaces. Who saw Kat's talk here last month? Okay, so like most of the people, so that's good. So we'll build on that. And then we'll look at build tags, what they are, how we can use them, and we'll tie it together to make awesome, fast, reusable integration tests. And a bit extra time. Okay, so I would assert that there's two types of tests, right? Unit tests, which are fast, but they're not really realistic, and integration tests, which are slow, but they actually test the thing you actually care about. No one wants to maintain two test suites, so maybe we can get the best of both. And I know unit and integration tests are overloaded terms. They mean something different to everyone. Here, by unit, I mean an isolation test. It doesn't depend on external services or databases or things like that. It's very portable. And by integration, I mean the opposite of that. So tests that depend on having a database running or that sort of thing. There's more nuanced discussion to this. There was a good Twitter blog post the other day on the engineering blog called #featuretests that spawned a bunch of drama on Twitter about you should have 10 times as many unit tests as integration, bollocks, whatever. We're not talking about that right now. So how do we make our tests better and separate these two types of tests? So let's talk about interfaces a bit. So why are integration tests slow? Right? Because they dock to real services. So what if we could run our tests with a different, faster database during tests? Interfaces are kind of the key to that. So one of the things that came up during Kat's talk was hexagons, I think. She didn't use the word maybe. Oh, okay, there you go. So yeah, so what she was talking about gets called hexagonal architecture, ports and adapters, functional core imperative shell. Like, they're all kind of the same thing. So hexagonal architecture is a way, I would say, to structure your app to make the best use of interfaces. So you start in the middle with your domain, the business logic, right? This is the core of the thing. They're all kind of pure functions, your data structures. It's very abstract at this level. And then for each protocol, you want your app to speak. Maybe you do some SMTP mailing, you have a REST server, you talk to a database over SQL, you add an adapter around that. And then finally, we build the mother of all adapters, the executable binary. And to glue these layers together, we're going to use something I just invented here called nod rule, which stands for no outward dependencies. So the things in the middle can never import the things on the outside. Like, you can never import package main, right? So it's just extending that a bit further. So to put the thing together, we have to run the imports the other way. So the binary imports the adapters import the domain logic, right? And then to pass data back the other way, our domain exports interfaces that the adapters can fulfill. It's really similar to what Chad was just talking about. And it works really well with Go's interface system. These kind of interfaces are the ports in ports and adapters. So let's go through an example. We'll see how this works, and we'll write some tests for it. I've been really enjoying the halftime, break time quizzes that we've been having on Go. So let's make a little quiz app. It'll be simple, but it'll have a database connection and some small bit of domain logic. And it'll look something like this. So we have a main file, and we have a database package. This is our real database adapter. And we have the quiz package. This will be our domain logic, right? So the answers.go will be what we're trying to test. This is a piece of domain logic. And we'll write our tests in the answer test.go. And then the magic bits will happen in the integration and unit test file. So because the database in this is an external adapter, our domain logic here, the quiz package, has to provide an interface that it can fulfill. It's kind of a slow thing. We don't want to depend on it. So AnswerDB will be that interface for this example. And it's pretty simple. We can save answers, and we can get them back out again. That's good enough for now. And submit answer is kind of the action, right? It takes the database, the kind of abstract idea of a database that can deal with answers, does some validation, and saves it. This is the basic app structure. I've kind of left out a REST API or something like that. If we were doing this, we would probably want one of those as well, but it would fit in similarly. So how do we test all of this? So let's write a simple test for this. This is kind of the skeleton of it, really. So we want to test that submit answer saves an answer. Here we're testing it for the domain logic. Normally for integration tests, you'd probably do it at like the REST layer, but didn't want to get into HTTP too much here. The important bit in this test really is the setup and cleanup phases. Setup is connecting to or creating a test database for us to use, and then the cleanup is doing whatever cleanup we need afterwards. Kind of does what it says on the tin. So we need to define these, but first let's just go through the rest of the test quick, and then we'll go see what those look like. So the test can be pretty simple. We can arrange our test data, we'll set up an answer, we'll act on it, we'll call our answer into the database, and then we'll just check that it was saved. One of the things which is a bit worse with this approach is that we have to use the getAnswer method on the database itself to check that it worked. We can't kind of circumvent that to do like a raw SQL query into the database to see if it worked. Okay, so that's that. So how do we implement setup and cleanup? So as I was saying earlier, I would again assert that there are two types of tests. It's this slide again as well. It's the same joke. You can define, so using these two files, we can define two copies of setup and cleanup, right? And then we can use build tags to select which one we want to run at the time where we're running the tests. Now to use build tags, we'll need to define this setup and cleanup in parallel in two separate files, one for unit tests and one for integration tests. So what are build tags? Okay, so in the docs, they're also called build constraints in a couple places, which tells you a bit more about what they do. They look like this. They're the first line in your file, and I mean the first line in your file. No package, no nothing. They're like the first line. And they're a way of selectively including files in builds, or excluding files from builds. So for example, this would include this file when we're on Linux and we're not using Seago. So you can do kind of Boolean operators on them. We can combine multiple build tags. So this one says, if we're on Linux or Darwin, and we're building for 386, include this file. You need to have a blank line between these and your package. I'd lost like an hour trying to figure that out. I was like, why isn't this compiling? So watch out for that. So what kind of things can we target with build tags? There's a big list. So operating system and architecture are the big ones that you see a lot. These can also be done by file name. So if you have an _linux.go on your file or _darwin or whatever, that's all we'll say about that for now. You can target which compiler you're on, whether Seago's enabled, what version of Go you're on, or from the docs, any additional words listed in context.build tags. Now context.build tags gets populated by whatever's in the files. So we can do custom build tags, any additional words we want. So for example, we were building a custom version of the program for LondonGophers. We could add a LondonGophers build tag to some files. So now this file will only be included when we call go build with -tags LondonGophers. Otherwise, this file won't be in there. Now, the nice bit is go test also takes a -tags flag. So we can use the same thing in our tests as well. So to do that, let's look at our integration test.go. We're ready to build the setup and cleanup functions now. So this is kind of the skeleton of it. We have our build tag, and we're saying only include this file when we're running with tags integration. And then we define our setup and cleanup following the kind of interface that we used in our tests. And the setup and cleanup is pretty straightforward, really. We just connect to our database, we truncate it. Okay, you know, you don't run that against production. You should probably use, you know, nested transactions or something, which would make your tests faster as well. But let's talk about that another time. And then when we're done, we just do some cleanup. Close the database connection so we don't leak sockets everywhere. There's also a nice little bonus you can do here. I mentioned that the go test command takes a -tags. When you run it, it also calls flag.parse from the standard library. So if you add any flags in the global scope, they'll get parsed. So they go straight onto the go test command. So here we've added a db-url flag. So when we're running go test, we can specify which URL we want to run our integration tests against. So if we're in CI and the database host is on another host, we can connect that up. It's a little bit of extra customization. You don't need that. Just a bonus for you. All right, so that's our integration tests. We can run our tests against a real database now. How do we want to do it to make them faster? We want to define our unit test variant of things. So this is the inverse build tag. So now we have our, if there is integration tests, if there's not integration tests, we're going to pick one of these two files. And in here, so we're saying when we're not doing integration, use this definition of setup and cleanup. And it's really simple. It just makes a map, basically. And we're just going to key the answers by ID on the map. It implements our answers DB interface, has a save answer and a get answer. Maps will get you a long ways for testing stuff. They're fast, they're portable. It's at least a good place to start. So to run the test now, we have kind of 3 different go test commands. The basics, by default, we just do go test, right? We get our fast tests, like a couple of seconds, you know. And then when we want to actually run a full integration test, we have a database running or we want to launch one or whatever, we do this dash tags integration. And then maybe for CI, we have to customize where that's pointing. We do this dash DB URL flag that we defined that gets bolted onto the go test binary right in there. And it's really slick. So this is all great. Am I hiding under the carpet? Why does this suck? So this works best for end-to-end and integration tests, right? When I say unit test in this talk, it's not like a true unit test. It's just kind of isolating things a little bit. So it's not universally applicable, maybe. And you do have to be careful about your test setup. All of your database setup, like if you're creating user accounts, you have to go through your database interface that you've defined, right? So maybe you have to add a few helper methods, like we had to add getAnswer to our database interface to support that. That's a little bit of a lie. You can add an optional test-only database interface and then do type inference to get into it, but it gets a little bit hairy quickly. If you do that, and you do want to do database truncation, that's a really good place to do it, though, because then you don't have to build it into your production code base, which is scary. But why is this awesome? So we can write fewer tests, right? And we can reuse the tests we have. We get fast, easy to run tests by default on my laptop. I'm developing stuff, hit run the tests. A few seconds later, I get my results. I don't have to launch databases and all this stuff. And then when we're ready to deploy on CI, we get realistic tests. We can check that our SQL queries actually work correctly with the data that we're feeding them, and the whole thing fits together. That's all I have for this time. Questions? Do we have time for questions?
Yeah, sure.
Okay, cool. What am I doing? Okay. I'll stay on this side. Okay, I just switched off, so. I can't cheat on my notes now, man. Come on.
Do you want to ask the question, then we'll ask
Yeah, let's do that.
Just quickly, you said that access would be at the very first line when you say it's
Yeah.
very important that package comes
Has
after
the- yeah.
every line. Does go prompt automatically insert one if it's not there? Because that sounds like something go prompt should just do.
That's a good question. I don't think.
You said you spent an hour. Did you ever
Yeah.
write go prompt? And it's okay. I've had these things before, so it's the same.
I don't think it differentiates between. Sorry. Does GoPump automatically insert the blank line between your build tags and your package definition? I don't think it differentiates between just a comment and a build tag. It just treats it like there's a comment at the top of your file, so no, unfortunately. That would be nice.
So when I use build tags, I get into trouble a lot because those aren't checked to match everything at compile time while I run with the build tags. Does that bother you?
How do you mean, sorry? Sorry, I'm trying to think how I could repeat the question.
The file that's excluded by build tags
Yeah.
doesn't get checked for compiling.
Yeah, okay. Yeah, that's true. So if you have that can be an issue sometimes. So basically, if you have a file excluded by build tags, GoBuild treats it like it doesn't even exist. So it won't check for compilation errors in there. So this, it does come up occasionally if you've just been working along running your unit tests, and then you go and you push your PR and the CI runs it. It's like, oh, it failed on integration tests because I forgot to run those and I forgot to update the database thing or something like that. And it doesn't compile in the first place. So that can be an issue. Generally, it'll come up quickly. Most of the time for me when I'm doing this, I forgot to add a method to the database implementation in my integration or my unit test or one of those, right? And I wrote a match that way. It can be a headache. It's generally a pretty straightforward, it doesn't compile. Okay, fix the 2 lines or whatever I need to. That is a caveat though.
So I've been using this kind of trick for a few times. Some days ago, even weeks ago, I'll make a man come up with say, oh, I thought you used environment variable. And I didn't have a good answer for him. So do you have a good answer?
Okay, so why wouldn't you just use environment variables, basically? Yeah, you can do. It's nice to not necessarily have, so in the case of doing truncation and stuff, it's nice to not include that code in your production code base at all, in my opinion. It's just kind of a tidiness thing. You can do it with environment variables as well, yeah.